Imagine a world where a single billion-dollar reservoir could hold the key to saving millions of people and acres of farmland from crippling droughts. To deal with its increasingly harsh environment, California is investing billions of dollars in a brand new, groundbreaking mega-reservoir. But why would one reservoir be so astronomically costly? And why would a single project take nearly a decade to build, demand futuristic technology, and push the limits of engineering? The state of California has faced endless droughts and floods throughout its history. And on top of that, the sudden environmental changes have worsened these conditions. Temperature changes are causing snow to melt earlier and faster, putting the water supply of the state in danger, which is mostly dependent on the snowfall from the Sierra Nevada. This disruption makes it difficult to store and use water throughout California's long, dry summer seasons. California has also experienced more frequent weather extremes, leading to both prolonged droughts and more intense floods. This combined threat highlights the necessity of effective water storage, especially to support the state's agriculture and urban areas, which face growing water demands. In order to combat these challenges and needs, the site's reservoir has been carefully and strategically planned in Northern California near Sacramento River, but off the main water channels. The reservoir is called Sites for the small hamlet where it is located, a small village of only a few people tucked away in a valley of the Coastal Range Mountains in rural Colusa County. With a capacity of 1.5 million acre-feet, the reservoir is expected to store enough water to supply around 3 million households annually, particularly capturing excess water during heavy rains for use in dry periods. The project's goals are to improve California's water resilience, lessen the strain that droughts place on ecosystems, and promote the state's long-term water security. This mega-project is estimated to reach a staggering $4 billion due to its complex design, engineering, and environmental factors. Unlike traditional reservoirs, Sites Reservoir would not dam a major river directly. Instead, it will redirect extra runoff from the Sacramento River during times of high flow, collecting and storing it. The goal of this off-stream strategy is to reduce environmental disturbance to the river and its ecosystem. The process of diverting stormwater while protecting fish and other organisms would require state-of-the-art technology. Flow rates must be carefully controlled to ensure that water diversion is sustainable, and complex environmental control systems will be necessary to protect sensitive ecosystems. More than 180 miles of conveyance channels and pipelines will be constructed in order to deliver water from the Sacramento River to the site's reservoir. These pipelines must also integrate seamlessly with California's existing water infrastructure, allowing the reservoir to distribute water efficiently across multiple regions. Fish screens and other barriers will be put in place to keep fish out of the reservoir's intake channels in order to lessen the ecological impact. Other than that, adaptive flow controls will help balance stable water levels in connected rivers, minimizing stress on aquatic organisms. Funding for the site's reservoir comes from a combination of state funding, federal grants, and investments from local water agencies. This mix helps offset the cost across different stakeholders while also ensuring diverse buy-in from agencies that will benefit from the reservoir's water supply. The main investors for this megastructure include the Metropolitan Water District of Southern California and other major water agencies. In order to match investment with the expected water benefits, their contributions are dependent on the volume of water storage they get. By encouraging involvement from areas with high water demands, this allocation-based strategy guarantees that the reservoir is profitable for its partners and that expenses are distributed according to expected usage. Sites Reservoir is intended to collect and store the excess stormwater from the Sacramento River. This requires carefully placing intake sites along the river to catch water at times of high flow. In order to preserve the well-being of the river, the system is designed to safely redirect water without substantially altering the natural flow patterns. Advanced fish screens are incorporated into the intake sites in order to protect fish and other aquatic organisms from being drawn into the reservoir. These advanced screens are made to adhere to strict environmental regulations, letting water flow through while protecting fish and other species. The site's reservoir project also includes the advanced screening technologies to filter water efficiently while making sure that the native fish population is protected. To keep tiny fish and larvae out of the intake systems, these screens use fine mesh and other barrier technologies. Additionally, they can be adjusted to let more or less water flow based on the time of year and the surrounding environment. The water must be transported to and from the reservoir through a network of pipelines and channels after being collected. This network will connect to California's existing water infrastructure, allowing for efficient distribution across agricultural, residential, and commercial areas in need. The 180 miles of conveyance pipes and channels that are proposed are designed to accommodate different elevations, pressures, and topography. Managing the speed and water flow, especially during high demand periods, requires a precise control system. The network is one of the most complicated components of the project since it must undergo extensive testing and calibration to guarantee that it can manage California's diverse geography and environmental requirements. Compliance with regulations from agencies such as the California Department of Fish and Wildlife, CDFW, and the U.S. The Environmental Protection Agency, EPA, is crucial. These restrictions provide strict rules for water diversion, habitat preservation, and monitoring. Advanced climate data and modeling tools are used to forecast water demand and availability. By storing extra water in preparation for dry spells and permitting increased flow during storm forecasts, this predictive technology assists operators in making adjustments ahead of time. The site reservoir is scheduled to break ground in 2026 and is estimated to be completed by 2030. The initial phase of its construction includes preparing the land by clearing vegetation, leveling the terrain, and setting up access roads. Intake structures along the Sacramento River will be built early in the process since they are necessary for collecting water during storms. The next phase requires laying pipeline segments, connecting channels to the reservoir, and setting up the necessary pumps and flow control system. The last steps include building the dam walls, spillways, and water control structures that will serve as the reservoir's main body. Every component is made to withstand high water pressure and guarantee stability over the long run in California's unpredictable environment. The site's reservoir demands cutting-edge technology to meet the standards for sustainability and safety. Laser-guided graders and GPS-enabled excavators will help accomplish exact cuts and grades, which are required for stable embankments and pipelines. To keep an eye on vital parameters including water levels, temperature, flow rate, and quality, the reservoir will use a network of sensors. Real-time information on the integrity of the infrastructure, including variations in the pressure inside the reservoir's walls and pipelines, will be provided by sensors. Data from these sensors will be analyzed that would in turn adjust the water intake and discharge in response to different environmental conditions, such as drought or rain. The emergency management system consists of modern alarm systems that provide early indications of problems such as high-pressure buildups, blockages, and structural tensions. Automated controls can initiate safety procedures, including lowering water intake or modifying outflow to relieve pressure in the event of infrastructure hazards or outside threats. The cutting-edge technologies powering the site's reservoir project make it a transformative solution for California's water security, yet they also drive up its costs significantly. The site's reservoir project is reaching an important turning point in its development. The reservoir might significantly improve water security for both urban and agricultural areas thanks to its innovative off-stream design, which is expected to catch rainfall and ease California's water problems. The stakes are high, and the potential benefits are massive. Will site's reservoir become the game changer we need? Only time will tell. The site's reservoir is more than just another water project. It is a significant step towards redefining water resiliency in California and beyond. as climate change worsens and droughts become more common. The reservoir promises not only relief, but also innovation, combining innovative engineering with sustainable methods to protect water in ways we have not seen before. Let us know what you think in the comments below, and do not forget to like, share, and subscribe to our channel.